So today's problem is maximize the confusion of the exam 2024. I'm gonna read this problem and then I didn't submit anything here, so I need probably a couple minutes to get the problem to read it, and then I'll start solving it. Let me check if everything is okay here. Default. Let's put this. And then screen is okay, so we'll start. Okay, so here we need to maximize consecutive number of true or false by doing k at most k operations. Operation is changing true to false or false to true. Okay, so in this case, if you change only the first one, you're gonna have 3. If you change the first one from true to false, you're gonna have a sequence of false as 3, and this is a basically maximum. And we can also change the last one true to false, and gonna be 3 last falses, it's also gonna be 3. If you change false to true, any false to true here, then it will be maximum 2. Okay, in this case, generally speaking, I can just change one of the falses to true, like this one, and get 5. Same way as here. If I change any kind of, if I change true to false in the beginning, and then maximum consecutive still gonna be 2. If I change it here, it's still gonna be 2. Sounds worse. What about constraints? So we have n 10 to the power of 4. Okay. So the first basically brute force solution. What can I offer for the brute force solution? I can select basically k places out of like n questions, and I can change them to opposite, and I can check like one place out of n, two places out of n, so on and so forth, and up to k places out of n, change them to the opposite, and then check if it's gonna be the maximum consecutive. So for the checking maximum consecutive, I can do that O of n, and then for the like selecting all this, so like I'll have C1 out of n plus C2 out of n plus C3 out of n plus Ck out of n. This all sum multiplied by n. That's gonna be O of n. O of this one. So the time complexity gonna be like this. Time equals O of this. And we have n 10 to the power of 4, even 5 by 10 to the power of 4. So we have n 5 10 to the power of 4. And this one, to calculate this one, this is like n factorial by 1 factorial, n minus 1 factorial, plus 2 factorial, plus n factorial again, then 2 factorial, n minus 2 factorial, and so on and so forth, then n factorial, k factorial, n minus k factorial. This one and this one, so it's gonna be n by n minus 1, n by n, no, just n plus n by n minus 1 over 2 plus n by n minus 2 and minus 1 n minus 2, so on over 3 by 2, and then so on and so forth. That's all multiplied by n. So it's pretty like complex if like just n is going to be 10 to the power of 5, and if you just take the first term, it's going to be also 10 to the power of 5, but it's going to be even higher. So it's going to be like bigger than 5 10 to the power of 5, and here also 5 10 to the power of 5, so it's going to be bigger than 10 to the power of 11 by 2. Yeah, but it's not acceptable here. So if you're gonna have this window, it should be something with the window, sliding window. So whenever we kind of let's say we have like here we have 2 keys maximum. So let's say I have this one, and you have, let's say, 2. Equals to, let's say 2. Oh, I say have one initially. So I'll have this. What we'll have? Let's say we have pointer at t. Then we have, let's say, we'll have t equals 1, and the last sequence last sequence equals like 1, and character equal true, and then max equals 1. So there are, and k equals also 1. So there are 2 possible options. We either change it to true, and then we'll k, what k can be? K can be less than n, less or equal n. Okay, so we can keep it as a true, the index element at index 1, or we can change it to false, true to false. And if we keep it to true, the max sequence gonna be equal to last sequence equals 2, and then last sequence character equals true. So if we change it from true to false, like at the index 1, then we'll have max sequence carried from here 1, and we'll have the last sequence equals 1, and the last sequence character equals false. And then we'll have like k equals k left. How many keys we have left? Key left. How many keys we have? We have key left here 0, and here we have key left 1. if we do the same from here, so it's like branching, looks like branching, but I don't want it to be branching, because every time we have like to choose, if we have key left, we have to choose either we change it to true to false, and we change the flag, and we try to follow both directions. We change it, we don't keep it the same. If we change it, we decrement the key. So here also we need, so it was at I equals 0, this is I equal 1, this is gonna be I equal 2. So we have keep it, so this branch gonna be keep, that's gonna be change. So keep, if you keep, then max sequence gonna be left 2, and then last sequence, because we keep whatever we have it, and it's different from the last sequence, so it's gonna be 1, and then last character gonna be false, and then key left equals 1. If we gonna change it here, then max sequence gonna be equal 3, last sequence gonna be 3, and the last character gonna be true, and key left gonna be 1. And then if we follow, then I'll have this this following, and in the end I'll have the, if I build this tree, every time I'm approaching I go O of n, and then I'll have the like either change or not at the index, in the current index, change or not the flag. So I wonder if I can like somehow optimize this one. What I'm not okay is this K. So K should be kind of its range of like it's the same as n, and of n, it's the same as n, and n is like 10 to the power of 4. And if we're gonna have like k by I index, the k is number of left. Let's say we, and that's gonna be the maximum we can get if we used, let's say, if we at index I, and then if we, let's say we used key changes. And they also gonna be like whatever is the last index, true or false. So it's gonna be like 3-dimensional already. And say we are in the middle of TTF, TT, TTF, 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 and then in the end we have T and T. So we can change maximum 1, and in this case it's gonna be gonna be a very interesting task. How we can solve it with of n, or maximum of n log n. I wonder if I should somehow so if I gonna count the number of count the number of like sequences, like we have like here T 1, and here we have T2, and here we have T2 F1, and here we have T2 F1 T1, and here we have T2 F1 T2, and here we have T the same, but T2 F1 T2 F1, and here we have T2 F1 T2 F1, and then T1. Here we have T2 F1 T2 F1, we have T2. So if you have like this, then like what matters is like only the last sequence of truth or falses. So then we need to figure out what the maximum number of we need to maximize confusion, and confusion is defined as like what? maximum number of consecutive t's or falses. Maximum number of t's and falses, truths or falses. So if I'm gonna do this maximum number of truths or falses, it seems like there are two states. First state is K. It's like states with the two variables. K is like number of used ops operations, and then the second state is like the end of the array. So in this case, you'll have like only the tail changes. So we have like here like maximum 2, here we have like maximum 2, here we have maximum 2, here we have maximum 2, here we have maximum 2, and here we have maximum 2, and here we have maximum 2. But we haven't done any changes in operations. So if we say we have max number of max number of consecutive is equal x now if there val e equals val e plus 1 e minus 1. If it's equal at the end, Okay, so the idea is the following. I guess I got it. So we don't need to count all the sequences. We only need to basically do this one. TTF, TTF, TT. And what I need to do, so I have a window of current window of maximum current if so I have a current window, and what I need to check, um, it's sequence like 2, and I need to check what's number of keys I have left. I have keys equals 1, so it means that it means that I'll have at the F, I'll have like two possible options. Window that closes at like 0, window closes at 1, window closes at 2. So for the window that closes at 2, we have two possible options. We change F, we keep F in this case. For the window that closes at F at 2, the sequence is gonna be 1, and if we change the sequence from if you change it from false to true, then gonna be the same as max sequence at the previous one, because previous one ended with true also. So on every so if I gonna go one by one, for when we change F, I need basically to reset the counter of used keys. Reset the counter. So for the okay, let's say we have pointer at 0. We say here we have pointer at 0. What the max sequence if we use so much max sequence if at 0 we end with T and use 0 0k at 0 T and then use 0 keys. So the max sequence in this key is gonna be 1. If we go at T 0 and we use one change, so we change true to false, k, if we use k equals 1, then max sequence is gonna be 1. And again it's gonna be end with true, and with true, and this is gonna be end with false. So we jump to the index 1, and we say, okay, what's gonna be max sequence? If we change it, if we change it, if we keep it, let's say we keep it. If we keep it, what possible options there? So if we keep it, we'll have I don't know. Let me check what we have for the time there. Oh, 36 minutes.